Hello, my name is Patricia Slint. I am the founder and CEO of Wings, the Smart Bag. We have created this handbag slash diaper bag slash space bag to help multitask women and men that struggles every day with their bags. The problem is that millions of individuals have experienced the same thing I had as a working mom, not be able to find anything in my bag and also not be able to find the right bag for myself. Wings is a unisex, smart, and personalized bag created merging today's technology solution to a high-end fashion product and leverage the demands for a unique bag. It comes with lighting system, USB driver, also with warmer bottles and warmer wipes, and also comes with an app that is attached to it and sensors. Our target audience are women and men between 20 to 55 years old. I have used my own experience to create this hand diaper bag to help people multitask like myself, regardless their gender or occupation. Wings stands for my daughters, Virginia, Isabella, Natalie, Sophia, and Sarah. My truly inspiration to find the solutions for bag. Thank you.
Hello, my name is Fauzi Tattoo.
My name is Juan Chang.
And my name is Ahmad Al-Tahan.
And this is our Intelligent Bag presentation for Professor Wiggins' Engineering Graphics class. So I'd first like to start off our presentation by addressing the major problem and the main purpose of our Intelligent Bag design. Ideally, a bag should be stylish and functional in almost all situations. However, that is not always the case, as we see here. We have identified three major limitations to the typical bag that have caused millions of people around the world great stress. The first issue is that it can be extremely difficult to locate and identify objects that are dispersed in a bag, especially when the visibility is low. The second issue that we have identified was that the typical bag is not capable of charging cell phones and other similar devices, which can be vital in emergency situations, especially when no power outlets are available. The third limitation to most bags is that they lack the proper cooling and installation that is required to preserve food over a long period of time, which is especially problematic for commuters that are in a rush and have to store their food for later, and for women who have to worry about carrying a separate bag and a lunch kit with them to work. These limitations cause a stressful effect that our intelligent bag design hopefully shall mitigate. So in our literature review, we did some research on bag designs, and we found some great design ideas that we could build off of. For example, the Light Up bag by Carrington was a pretty good idea, which utilizes a self-contained lighting device, which aids in locating objects within the bag. Another great example of intelligent bag that we found is the Build Your Own bag, known as BYOB. It utilizes a similar lighting sensing capabilities to eliminate interior of the bags. All these bag design ideas were instrumental in helping us create our own bag. They served as inspiration and gave us some great ideas. So going to the next slide. So before we had to get started, we had to make a list of requirements that intelligent bag had to meet. We first had to incorporate some kind of electronic device with an on and off switch and light sensor, which would allow us to illuminate the interior of the bag, allowing for easy identification of the objects within the bag. Our bag also had to have the capacity to charge electronic devices like cell phones. We also wanted to utilize a cooling feature, which would allow us to preserve food that is stored in the bag over an extended period of time. We also made a requirement to utilize SolidWorks 3D model to design our own unique version of the bag. Our goal was to fulfill all these requirements while also providing an affordable product for our potential customers. So going on to the next slide. So the materials that were required to create an intelligent bag as pictured above are the laptop bag, a small insulated lunch bag, flippers, LED strips, thermal electric cooling feature, and the Arduino playground, an all-in-one programmable board that has sensors and LEDs built in. Going to the next slide, as you can see now, utilizing the SolidWorks software, we created a 2D blueprint of our unique bag design. As you can see here, there's different views pictured. We have the top view, front view, right view, bottom view, and we have dimensions in the units of the bags, the sizes. We're going on to the next slide. Here's the 3D model of our unique bag. As you can see, we put the Sanjak logo on in the front, and we made it blue to, that's our school color, Sanjak, just to show off for our school. And this is our unique bag design that we created using SolidWorks, different views. So now I'm going to hand it off to Tim. He's going to go over the methods and the analysis that we use to make this bag.
Thank you, Fauci. I will talk about how we code the Arduino Playground Express. First of all, I set up all the pixels will turn off and set up also the LED tree, and the database will read from A1 port. So in this system, I also set a switch for this. There are two sides of switch. You can switch to right or switch to left. Okay. I also set the graph for the light level because we wanted to determine which light level should be in real environment. In this case, I choose a 7 after many tests. And when the light level really dark and the switch turn right, the light will automatically turn on. And you turn the switch to the left, and I call this is a sleep mode function, and you will turn off the LED light, but the PCB will turn on with the low light. It still make you could do the thing in your bed. I'm back to the real design for this bed. You could see that every strip I put around in the past to make sure that we have enough light in the past. And the Arduino Playground Express I put in the center of the bed because I want the light sensor work well when we open the bed. And you could see that in this case, in the low light, the bed will turn automatically the light on. And it will be really easy to find the stuff inside the bag. I would talk about Arduino Playground Express and why I pick this. I should say it's really easy for coding. It takes me only 1 day to coding and support by Microsoft on the website MacCode. The PCB also have the affordable price. It's only $25 for this PCB, and it was supported by the large community support. It means when you have a new idea and you don't know how to coding, and you could find your answer easily. I used to use Arduino Uno to code for some another process, but compared to this PCB Playground is that it has a lot of sensors such as light sensors, sound detection, motion detection, and iterative buttons. I should say it's easy for me to express my idea. I also use a thermometer cooling fan initially to make a cooling pocket. It's a lightweight of the fan and really safe because it consumes a lot of electricity and it also has a mobility of this. So Armand will talk about the price and quantity of this bag.
Thank you, Mr. Tim. All right, you guys, I'm going to talk about some of the devices we're using and the economical reasons behind our choice. And finally, I'm going to sum with the cost and price of our product. First device I want to talk about is the Arduino Playground Express. Before I talk about this device, I just want to talk about the Arduino company. Arduino is one of the most famous open source hardware and software companies around the world. That is the reason that we were actually interested in their devices. Going back to the device itself, Arduino Playground Express has easy coding. As I mentioned earlier, guys, this company is known to be an open source hardware and software company, which means that the original source code of its devices is made freely available and could be modified to users. Second feature is its affordable price compared to the services it offers. The playground, this specific device, the Arduino Playground Express, retails at around $25 and wholesales for around $18 per unit. Thirdly, and most importantly, it's community support. As I mentioned, this is a very widely used device all around the world. There are plenty of useful modified codes for the light sensor, sound detection, and motion detection, and basically all kinds of features of this device made by the users. That I want to talk about is the thermometer cooling fan. Some of the features behind our choice of this device is that it is lightweight, it is safe, it consumes its lithium battery allows us to have allows it to consume a low amount of electricity. This specific device allows 24 hours of usage before its batteries are required to be recharged. And finally, its mobility. Finally, I want to talk about the cost and price of our product. Our material cost is estimated to be $50 per unit. Labor cost is estimated to be $7 per unit. And finally, a fixed cost of $5 per unit, which takes us to around a total of a protection cost of around $62 per unit. Of course, we're aiming to decrease that amount by at least 20% by moving to wholesale, but that's our current production cost. With our current production cost, we're planning to have a sales price of around $90 compared to the $150 market price for products with similar price, which also allows us to have a $28 profit margin per unit. Finally, I'm going to move it back to Mr. Fauzi.
First, I would like to acknowledge Patricia Sland, the founder of VINS. She pretty much helped out with Wiggins to put up this idea for us so we could pursue this intelligent bag design. She has her own website. I recommend you guys go check it out, vins.com. She's an expert in the intelligent bag design area, and if you guys have any questions, I would go and check her stuff out. It's really impressive stuff. Also, we want a big thanks to Professor Wiggins. Without him, we wouldn't have this project. He's a great professor at San Jack, and it wouldn't be possible without him. And also, I want to just thank the college, San Jack College. It's the best college in America.
Okay, this is which we reference for this process, and we want to show you how the bag it really works.
So here's something we added. We think it's really important: outreach to the community. About a month ago, we went to San Jack Central Campus, and we provided hands-on STEM training to K-12 students in our community, just to inspire them to get interested in the STEM and engineering fields. We actually think that, all engineering students should do some kind of outreach. It's really good for the community, and you don't know who you might inspire to be the next great inventor, some problem that we may have. So that's something we wanted to add because we thought it was really important.
I will open the video to show how the bag works. Okay, this is the bag in a real life, and when I turn off the lights, the light inside the bag will turn on automatically, as you can see, and it's worked correctly many times. Inside the bag, you easily to find your stuff, and your phone will be charged as well. At that moment, I turn on to sleep mode, and in sleep mode, the light sensor will be turned off. That's sort of all the function of this bag working. And thank you for watching.
Thank you, and that concludes our presentation. If you guys have any questions, feel free to leave a comment in the description. We'd be happy to answer any questions you guys may have. And from all of us, we hope everybody's doing well, is happy and safe during this difficult time, and we're excited to see you guys soon.
Thank you, and stay safe.
So this is our intelligent bag project. So our problem statement is, ideally a purse should be both modern and functional. Unfortunately, most women and men struggle to reach in their bag to retrieve an object. The reason why they can't retrieve their object is because they can't see. So we thought we would eliminate this problem by putting a light source into diaper bags, purses, backpacks, so they could see this object. So our requirements are that we will have a source of light, and the source of light would be a NeoPixel stick, and we would code that through an Arduino Uno board, and this would be triggered by light sensors or even a button sensor. Our source of power for the source of light would be a cat rechargeable power bank. And we would need protection for our Arduino board because, gotta protect our sources. And we just don't want it to be damaged or potentially get wet, because you never know what can spill in a diaper bag, a purse, a backpack, or even just the rain from damaging it. So this is going to be the design of our project. So this would be the side view of our purse, back view, top view, front view. So we're thinking that our light source would be in here somewhere on the side, and where we could potentially have some of the wires running through the fabric even. So this is going to be the cost of all of our resources that we use. So our materials, which would be chargers, wires, boards of the lights, would come out to $128.86. The labor, $30.71. Transit, $11.74. Duties, so that's like postage, taxes, anything like that, would be $4.71. And our total cost would come out to be $176.02. But what we're trying to do is have the sale price be around $300. And this is all our resources.
So we were tasked, this team here was tasked with coming up with a more modern, more intelligent backpack for the more modern, more intelligent person that does more than just hold your stuff for you. It actually contributes to your life in a positive way. Here we have our backpack. It is not just a backpack. It connects to your phone. It's Bluetooth adaptive. You can connect to it with pretty much any modern phone now and control its interior lighting. If you need to get into it in a dark place, your phone can activate that, or a switch can activate that, and you'll be able to see on the inside of that and get whatever you need. It also has GPS tracking for whenever the worst happens and someone tries to steal your things. They will not get away with it for very long because you will know their exact location on your phone. It also has rechargeability for your smart device, the one that, yes, connects to your phone. Also, ones that have USB charging. Any device can be charged from this backpack's internal battery. It also has a heating and cooling system, which also runs off the battery, so that you can have snacks, sandwiches, baby bottles, baby wipes, whatever you need. And also the backpack itself is incredibly durable. Here we have Josue to explain this slide.
Okay, hello all. We implemented the Adafruit Playground / Express to our system. We can connect, a Bluetooth module and a GPS tracking system. The issue we ran into with the Bluetooth, we don't have an app to connect to it, so we can't really control much from the phone. I mean, it'll connect, but you can't really do much. We don't have the power or the skill to create an app, so I'm not sure if one of the other teams or maybe later on down the line with the product you can create an app for it. That'd be really cool. But for now, the Bluetooth code did work, and we got it working with the Adafruit. The GPS tracking, it's there in case your backpack gets stolen, you misplace it, or you get lost in the wilderness. We'll be able to find you, which is a really cool feature. We had some issues with the output, but I mean that's just stuff that can get worked over time. But overall, I think it was pretty cool features for the smart backpack. And, since it is a smart backpack, to be able to connect with your phone would be exceptional.
So, like it was said earlier, the bag needs to be internally lit. And that lighting is going to come from an LED strip that is a 3-key controller. And it will be low voltage operating. It will have 16 colors, and it needs to be usable in different environments. So like if it's in a dark room, it needs to dim, or if you're in a very bright area, the light needs to be brighter. And waterproof, because again, it needs to be a durable bag. You need to be able to use it wherever you go. and flexible because the shape of the bag is varies and the bag can just change shape all the time. The LED type for the strip is a 50/50 SMD.
This backpack is gonna have portable chargers so you can charge your stuff, external devices, and durability. Rechargeability for external can be adaptive based on charging port. Internal battery will have 3 USB ports and be rechargeable for long uses. This portable battery will have a 6 amp max, which is a lot, and it has 3 outputs, and it has one input of 2.4 amps, which makes it faster to recharge anything.
We wanted to implement a heating cooling system, you know, for beverages, baby formula, food, if you have small enough food. So it'll be connected directly to the battery. The system has LED indicators, you know, for cool and hot. Is regulated temperature internally. And the issue we ran into is we couldn't run the heating cooling system out of the Adafruit. It didn't have enough voltage nor amperage. So we decided to connect it directly to the battery, and it'll run via a switch. You can put in a soda in there to get it cold. You bought a toasty sandwich, you can fit it in there. It'll get nice and toasty for you. We found this to be the better option because we'd run into so many issues regarding the amperage. You know, we had to get transformers and stuff like that. So we decided to just externally do it. And it'll be outside the backpack so the moisture doesn't, you know, damage the internal circuitry and stuff like that. We thought this was a cool feature, and we implemented it.
Awesome. Well, that was our presentation on our smart backpack. It can connect directly to your phone. It can tell you where it is, and it can keep your toasty sandwiches nice and toasty. These are our references. Thank you for watching.